So the next thing you're going to want to do is actually draw and construct the component that you're trying to model. What you want to do is go in under your component to the geometry node now. And basically, if you've ever used any kind of CAD software, this is going to seem very, very familiar. And actually, there's a lot of tools built into COMSOL, and especially with Simulink and CAD import tools that can bring it from other programs like SolidWorks or AutoCAD into COMSOL. So that's really nice. What you want to do is you click on geometry on the head node, you get the length scale. It's kind of arbitrary. Do you want to use in degrees, radians, etc., etc. And then what you have to do is build and add things like rectangles, squares, circles, ellipses, lots of different objects. And you can specify the width, the height. You can put in your parameters here. If you have a parameter defined there, here you can put that in, and that's nice for parametrically designing these things. Points. The point of having a point is that you can specify different boundary conditions or different probes or different variables or phenomena that's having at those points. So when we get into more kind of the solver process and we want to look at defining your boundary conditions, your probes, this is really handy. And again, you can also specify the properties in there. What you can do here is things like if you create, you can do Boolean logic on these. And what I mean is that you could say you have a rectangle over here already. Let's define a circle that looks, a little bit bigger than that. Okay. Build selected object. Now we get this object. What we can do, right click on geometry, go to Booleans and partitions, and we can say the difference. So we could take this object to add, and we want to subtract this one, hit build, and now we've taken a byte out of it. Very handy. We can also do things like chamfers. So you select your object, vertices to chamfer. So this particular corner, let's take that. We distance from vertex, say 0.05, hit build selected, and now we've taken a byte out on that side. So these are really useful to try and get the different geometries and match the engineering specifications. One other thing I do want to note here is that we can also define something called a cumulative selection. If you're creating a bunch of different parts of a component, sub parts, I guess, of your component, sometimes it's nice to define a particular variable. Let's say cut. Why not? You specify this. So this is what it's saying is that the result of this difference operation contributes to this cumulative selection called cut. When we build that, it adds on this new node here. And this was before we did the chamfer. So let's just delete that for completeness. Yep. Right. So what we've done now, we've used COMSOL and we've identified and defined one of these objects. So later on, when we go to define temperature, physics associated with that, plotting associated with that, instead of trying to select that block, we can now refer to that group by name. So if you have a complicated object, this becomes very, very useful in the future. These are the different things, are the different levels of the geometry. So your domain, in this case, is 2D. Your boundaries are literally the boundaries, the one-dimensionals. And the points are the different points that are present on that object.